All right, so we are getting ready to start talking about these trig identities, and we'll talk about them maybe for a full week or 4 days at least. Just doing different things with the different identities. We will have a quiz over them. I want to say a week from today. So we are starting this a little bit early because I want you to have plenty of time to have them solid in your brain. But some of them you already know, and you may not realize it. So, what is the sign the reciprocal of? Cosecant. So, the sign of theta is the same as 1 over the cosecant of theta. And similarly, sine, the reciprocal of cosecant is going to be 1 over the sine of theta. All right, so you guys fill in the other 4 blanks for the reciprocal identities in a similar way.
Just secant.
Is what just secant?
Like it's cosecant, secant, and cotangent.
Yeah.
Oh, it's reversed.
It's okay. So if you know what is the reciprocal of what, then you already know those 6 identities and you don't even have to study them. And you might already know the quotient identity. So as we've talked about tangent several times, we've written it as to find the tangent on the unit circle doing y over x. Do you remember how else it was written? Using trig ratios instead of x and y. Anybody remember? Sine over cosine. So that is a quotient identity. So the tangent of theta is also equal to the sine of theta divided by the cosine of theta. So that one you may already know. It's a pretty easy one to remember. And once you know that one, and knowing that the cotangent is the reciprocal of the tangent, what should the cotangent of theta be? Right, the reciprocal, cosine of theta over sine of theta. All right, and then this identity is, you might have talked about it in Algebra 2. I think some Algebra 2 classes did and some didn't. I don't know for sure. But it is a Pythagorean identity. There's 3 Pythagorean identities. This one is one you might know. Does anybody recognize it? That's okay. Sometimes they put it on the ACT in a way that if you know this identity, you can get that question right in like 2 seconds. Sometimes it's on there and sometimes it's not. There's 4 trig questions on the ACT, so it could be all different types of things. But anyway, if you take the sine of any angle and square it, and the cosine of that same angle and square it, and add this together, you get 1 every time. Do you want to see it, or you just want to believe it? Does anybody want to see it? Okay, it's fine. Some people need to see things to remember. It's fine. All right, so pick an angle that is on the unit circle for me, please. Okay. All right, so what is the sine of pi over 6? Yes. And the cosine? All right. So if I square 1/2, I just square 1 and square 2, and that's 1/4. If I square the square root of 3, that's just 3. And I square 2, it's 4. And I add those together and I get 1. And it happens for every single angle in the whole world. It doesn't even have to be an angle in the unit circle. It helps because it's on the unit circle because we can do it in our head, but it works. I promise it happens. All right, there are 2 other Pythagorean identities. And you probably don't know those, but we can always find them. And so there's a kind of an emphasis on our standards to know the trig identities, but if you don't know them, be able to derive them, which is what this lesson is kind of all about. So what we're going to do is take the Pythagorean identity, sine squared of theta plus cosine squared of theta equals 1. And we are going to divide through the whole equation by cosine squared. So we're going to divide each term by cosine squared. This is what your other paper is for. All right, so we just wrote that sine of theta over cosine of theta is tangent of theta. So what do you think that sine squared of theta over cosine squared of theta is? Nope. Sine squared over cosine squared. What was sine over cosine? Tangent. So what do you think sine squared over cosine squared is? Don't make it hard. Tangent squared. Tangent squared of theta. All right, what about cosine squared of theta divided by cosine squared of theta? That is 1. All right, we said that using the reciprocal identities, that secant is 1 over cosine of theta. So what do you guys think 1 over cosine squared of theta is? Secant squared. All right, that's another identity, Pythagorean identity. So write that in that second blank, please. All right, and then you guys are going to figure out the third Pythagorean identity on your own. So this time, I want you to take the sine squared of theta plus cosine squared of theta equals 1. And this time, we're going to divide by sine squared. So divide each term by sine squared of theta and see what you end up with. All right, what did you guys get? Good. All right. So you have 2 options. You can memorize all the Pythagorean identities, or you can memorize one of them and derive the other 2. Usually, I think what my students do is memorize 2 of them. So, like, memorize this one and this one. And then this one you can find just by taking this and adding co. Listen to this. This is important. So take this one, and where this is tangent squared of theta, change it to cotangent squared of theta. And where this one is secant squared, change it to cosecant squared. And you have them both memorized just by adding a co. So however you want to do it. But in about a week, you're going to need to know them all 3. Okay, let's look at the even and odd identities. So we haven't talked about even and odd functions in a while, but all the trig functions are either even or odd. So sine and tangent are odd. So on the odd functions, do you remember what happened with this negative? There's 2 options. It could jump out in the front, or it could completely disappear, like get absorbed in the problem. You may remember what you do for odd functions? It's been a while. Anyone want to take a guess? 50-50 chance. It goes in the front. So for the odd functions, the negative is going to be in the front. So the sign of negative theta is the same as the opposite of the sign of positive theta. And the reciprocals go together. So if sine is odd, cosecant is odd. All right, tangent is odd, so that negative is in the front, and cotangent, the negative, is in the front.
What do you mean they're odd?
They're odd functions. So an odd function, there's two things we can remember about them. One is that if you put a negative x in for x, you get the complete opposite. And they're also symmetric with respect to the origin. We talked about it. It was early, like maybe the first month of school. And then an even function, if you put a negative x in for x, it completely gets absorbed and you get the exact same function. Do you remember what even functions are symmetric with respect to? The y-axis. I'm pretty sure we talked about this. We're supposed to. It's been a while. You learned a lot since then. Okay, so just try to remember, this doesn't come up a ton, but if you have the sign of a negative angle, it's going to be the opposite of the sign of the positive. If you have the cosine of a negative angle, it's going to be exactly the same as the cosine of the positive. Okay, so let's talk about these sum identities. These are two that you're just straight up going to have to memorize. Now, someone in my last class was really concerned about the alpha and beta. Don't be. They're just Greek letters. It's just like having X and Y. They're just Greek letters, like having A and B. So please, life is too short to get stressed out about things like that. That's not important. It's just like theta. Don't worry. Okay, and so what we're going to do is use this guy to figure out this one. And so the only difference is what we're going to do in the place of beta, we're actually going to put in negative beta. All right, so we're going to do this on our paper. So what we're going to find is the sign of alpha minus beta by doing the sign of alpha plus the opposite of beta. Because they mean the same thing. They're just written a little differently. So we'll take that identity, and then we're going to leave alpha alpha, but we're going to change beta to negative beta. All right, so all I did was take that identity and I just wrote it with beta changed to negative beta. So what's going to happen with the cosine of negative beta? What's going to happen to the negative if cosine is even? Look at your identity sheet. It's going to disappear. It's going to be absorbed into the problem. So the cosine of negative beta is just going to change to the cosine of positive beta. What about the negative on the sign? It's going to bump out to the front, so that's going to change to minus cosine of alpha sine of beta. All right, so write that in that blank, please. For sine of alpha minus beta, read that guy. Right, now the cosine of two angles added it's different. Like, it's a totally different formula. The cosines are together. It's cosine times cosine minus sine times sine. So we're going to use this guy to figure out this identity. I'm going to have you guys do this one on your own, but I'm going to set it up for you. So what we're figuring out is what the cosine of alpha minus beta is by finding the cosine of alpha plus the opposite of beta. So we're going to use that. Second sum identity, the one with cosine, and just put in negative beta for beta, please. All right, so how is it compared to this one? But yes. All right, those are the sum identities. And it's kind of difficult today for you to see the usefulness in these, but sometimes you want to find the sine of an angle that's not on the unit circle and you can't use a calculator. So it's going to be the sum of two angles that are on the unit circle and you can figure it out that way. Okay, and then the last group is the double angle formulas. And so what we're going to do to derive this one is take this one. And so I want to be able to add two angles and get 2 theta. What would I add to get 2 theta? It's not a trick question. What plus what gives you 2 theta? Theta plus theta, right? Okay, so what we're going to do is we're going to take that sine of alpha plus beta, and we're going to make alpha and beta be theta. So in the place of alpha, we're going to put theta, and in the place of beta, we're going to put theta. And this is just so we can derive the formula. You can also memorize the formula. You just have options. If you're not a good memorizer, you can always figure them out. All right, are these two things the same? What's in front of the plus and what's after the plus? Are they the same? So what would you get if you added them together? You would get sine squared if you multiplied them together. What would you get if you added them? You'd get 2 of them. So 2 sine theta cosine theta. All right, so that's what we're going to write in the blank of sine of 2 theta. All right, so I want you guys to actually do this, to take the cosine of 2 angles added and figure out what the cosine of 2 theta is by making both of those angles theta and figuring it out. All right, this one looks way different, by the way, the sine of 2 theta. So if you got something way different, it's okay. It's supposed to be way different. All right, anybody want to give a guess? Very good. All right, so you're going to get cosine of theta times cosine of theta, which is cosine squared of theta. And then minus sine times sine, which is sine squared. All right, there's 2 more. And those 2, we can use that one we just found and the Pythagorean identities to figure out what those are. All right, so let's take the cosine squared plus sine squared of theta. Minus, I should say. And what we're going to do is we're going to replace cosine squared of theta with something else. And this is tough. Like what we're getting ready to do, you can't just like know what to do at the beginning of every problem. So you're going to have, sometimes you'll have to try something and it might not work. And then you try something else and it's okay. You just have to persevere and hang in there. So I'm going to tell you what to do. We're going to take the Pythagorean identity, this one, and we don't want this identity the way it is. We want to replace cosine squared of theta with something else. So what would you get if you solved this identity for cosine squared of theta? Like what would you do? If I want this by itself, what would I do with that? You would subtract it. So what should cosine squared of theta equal? 1 minus sine squared of theta. So that's what we're going to do. In the place of that cosine squared, I'm going to change it to 1 minus sine squared. All right. And then what do you think you get when you subtract a negative sine squared and a sine squared? So negative sine squared of theta minus another sine squared of theta. Thank you. All right, so that's what you guys write in the second blank for cosine of 2 theta. All right, and there's one more we're going to figure out. All right, so we're going to go back to that cosine squared of theta minus sine squared of theta. And this time, we're going to change sine squared of theta to something using that same Pythagorean identity. Be careful distributing the negative on this one.
So we're just trying to find sine squared theta, not negative sine squared theta.
Yes, just find sine squared theta. Okay, so using that same identity, if I want to solve it for sine squared, what would it equal? Everybody can do this, like honestly, if you've been solving equations for a long time. So if I want to know what this is, then I'm just going to move this to the other side. And you move it to the other side by subtracting it. So in the place of sine, oh, hold on, don't do that. In the place of sine squared, it's going to be 1 minus cosine squared theta. All right. Then this one is tricky because of the minus. So we do have to distribute the negative. And then you're just adding like terms. And that's it. That's the third identity for the cosine of 2 theta. All right, so make sure you get all these written down so you can study them. You have options of deriving them if you want to choose to do that. Do it that way. Memorizing them might be a little bit easier.
So our quiz is just gonna be like this sheet.
Yes. It'll be, the order will be mixed up, but I'll give headings, and so you'll have a heading with blanks, but they won't be in the exact same order. Right, and so start studying. We're going to use them every day for like a week almost.